Hello, grade 10 students. Welcome to the chemistry offline classes. Today the main topic is oxides. We are going to continue with the classification of inorganic compounds. We are done with acids and bases, but we still have the oxides. So get ready and let's start. Let's start by defining the word oxides. Oxides are compounds of oxygen with other elements. Oxygen is the eighth element of the periodic table, and it is colorless, odorless, and tasteless gas at normal conditions. What does it mean? It means that oxygen has no color, no odor, and doesn't taste anything. Oxygen was discovered by Joseph Priestley in 1774, and the name oxygen originates from the combination of two Greek words, and the words are oxus, that means acid, and genon, that means generate. The free oxygen is predominantly found in the form of diatomic molecules. You're always asking, Miss Umba, how should I know that oxygen is 2? It's because the form that is mostly found to be able to react is in the form of diatomic molecule. Oxygen is the most abundant element in the earth crust and in the air. In the earth crust, that is 49% by mass, and in the air, that is 21% by mass. There are only two kinds of atoms in oxygen. You're not talking about the quantity, but the type of atoms. Okay, for example, here we only have sodium and oxygen. There is no a third element. Okay, a third different type of element. Here we have barium and oxygen, nitrogen and oxygen, and silicon and oxygen. But in carboxylic acid, there is hydrogen 1, carbon 2, oxygen 3. And in sodium nitrate, we have also 3 elements. In ethanol, 3 elements. So although those compounds contain oxygen, they are not oxides because there is a third, a different type of elements. Okay, so remember that carboxylic acid, sodium nitrate, and ethanol are not oxides. Oxides are widely distributed in nature. We have silicon, that is the main constituent of sand, and we know that sand is the most abundant mineral. We have water, that is one oxide of hydrogen. We have nitrogen oxides that are dangerous gases pollutants. We have sulfur dioxide that is the same as the nitrogen oxides, are also gas pollutants. We have the carbon dioxide being expelled during respiration, that is from animals, plants, and human. And then we have the CO2, or the solid carbon dioxide, that is dry ice and is used as a coolant. Okay, so properties of oxides. Here we need to distinguish between metal oxides and non-metal oxides. The non-metal oxides, they have a covalent structure or molecular structure, so they have low boiling point and low melting point. In the case of metal oxides, they have ionic structure, and then they have higher melting point and a boiling point. Let's try to name the oxides. When we are naming the oxides, again, we need to distinguish between metal and non-metal. The metal oxides, we need to check whether it's only one oxide or there are more than one oxide. Remember the oxyacids, okay? That you need to see the more oxygen atom, the one that has more oxygen atom, and the one with less oxygen atoms. That is the same idea. The one with less oxygen atoms, where that is the possibility of one oxide, we use the metal name and oxide. Those who can have more than one oxide, in most of the cases because of the oxidation number, we need to use the metal oxidation number and the oxide. In case of non-metal oxides, we use the Latin prefixes, so we use the non-metal name and oxides, or the Latin prefixes to the non-metal and to the oxides. Okay, so the Latin number prefixes are this one: mono to 1, di to 2, tri, tetra, penta, hexa, hepta for 7, octa, nona, and deca. Okay, let's try to do this exercise very quickly. Let me get my pen. Let me also change the color. Okay, let me use this one. Okay, so the first one, what is sodium? Is a neutral. Okay, so we have the name of the oxide, we have the name of metal and the word oxide, but then we need to know if there is more than one possibility. No, so we have the name of metal and oxide: sodium oxide, calcium calcium, and then oxygen. That is also a metal, and there's no a possibility of another oxide, so we say that is the name of the metal, that is calcium, and then the word oxide. Okay, the word oxide. Okay, in in the case of iron, we can say that we have iron 2 oxide and iron 3 oxide. This Roman number in the brackets shows the oxidation state of the iron. Okay, the oxidation number of iron. Okay, so in that one means that the oxidation number of iron is 2, and for the fourth one, the oxidation number of iron is 3. Okay, so let's try to do to the first one. Let me explain. We have Fe and O. Remember that the oxidation number for iron is 2. It is 2 plus, and the oxidation number for oxygen is 2 minus. So what happened? They cancel. At the end we have FeO. Okay, but then in that case we have Fe and O. The oxidation number of iron is 3. Okay, so we have 3 plus, and the oxidation number of oxygen is 2 minus. Okay, remember that I said that the oxidation number, it goes after the other constituent. Okay, so the oxidation number of iron goes to here after the oxygen, and the oxidation number of oxygen goes after iron. So at the end we're going to have Fe2O3, so iron 3 oxide. Okay, have a look on this one. We have phosphorus and oxygen. Phosphorus is not a metal, so we are here. Okay, so we have non-metal. We need to use the Latin prefixes to the non-metal and oxide. It was P2O5. So P2 meaning that we have 2 phosphorus, we need to use di, and then for oxygen that we have 5, we need to use penta. So we have diphosphorus pentaoxide. Okay, so what does it mean here? If you have P2O5, okay, you should know that the 5 is for the oxidation number of phosphorus, and 2 for the oxygen. We have NO. N is nitrogen and O is oxygen. N is a non-metal, so we need to use the Latin prefix. Therefore, we cannot say a monophosphorus, mononitrogen, so we'll leave. And oxygen is one. We can include the mono prefix, so it will be nitrogen. It will be nitrogen monoxide. Okay, that is it. Good. That is the correct table. Okay, so here is the formula and the other one is the name. Let's try to solve this a simple exercise. We know that the oxide of 1A metal group in the periodic table contains 25.8% oxygen by mass, and then they say to find this metal. Okay, let's work with the molar mass. Okay, we know that if the element is from group 1, the oxide should be MEO. So it should be 2, that is the valency of oxygen, and 1, the valency for the metal group 1, so it's 1. Okay, here 1 mole of oxide contains 1 mole of oxygen atom, and 1 mole of oxygen atom, the molar mass is 16 grams. Okay, so let's think, if 25% of that oxide contains 16 grams, how many grams does the all amount of the oxide have? Okay, so we have 75.8 percent of the acid contains the 16 grams of oxygen. How about the percentage of for the 100? Okay, and that should be grams per mole. Okay, so if we do the cross multiplication, X has to be equals to 25.8 not grams of M2O, the oxide, and then we have 100% of that Me2O times 16 grams per mole. Okay, so this two will cancel, and at the end we know that we have 62 grams per mole of that compound. Okay, so if we need to do the molar mass of anything, of the metal oxide, okay, we know that the molar mass will be equal to the molar mass of the metal, okay, the molar mass of the metal plus the molar mass of the oxygen. Okay, so if the molar mass of, if we need to find the molar mass of the oxygen, this, because the question is find this metal. If we need to find the metal with the periodic table, we need the molar mass. Okay, so that is what we are looking for. So the molar mass of the metal will be equals to the molar mass of the metal oxide minus the molar mass of the oxygen. In that case, I have 62 grams per mole. Okay, minus 16. Okay, so the molar mass of oxygen is per mole. Okay, at the end I have 62 minus 16, that is 46 grams per mole. Okay, so that is the mass of the oxide 2. Okay, remember that is 2. Okay, it means that for 1 we need to divide this value by 2. Okay, so that will be, oh sorry, it's not 42, it's 46. Okay, 46, so it will be 46 grams per mole divided by 2. At the end we have 23, that is 23, not point, 23 grams per mole. Please go to your periodic table and check which element has molar mass of 23 grams per mole. Okay, did you find it? Let me go and check. Okay, so we have sodium. Okay, molar mass of sodium is 22.99. So the element is sodium. Okay, let's proceed. And that is the resolution of the exercise. So we have sodium. Oh, we are done. So the homework is to read the session in page 42. That is the reading session that is related to the properties of oxygen. You should know what are the properties of oxygen. Okay, so go and read and write a summary for me. The second one is this exercise. It says that the oxide of a group 2 metal in the periodic table contains 28.6% of oxygen by mass. Determine this metal. It's the same as this one. Just try to follow the same steps and you are going to find the answer. Remember that this exercise is in page 41 of your book. I'm going to upload this homework in Fedena. Thank you for being a participant of this class. I will find you in lesson 6. Goodbye.